Madi, if I may start to give a warm welcome to everybody, if that's okay. Yeah. So Assalamualaikum warahmatullahi wabarakatuh. While we wait for Dr. Lucy to come back, saya dan Dr. Hasharina, who is the head of Borneo Studies Network, currently the Secretariat Office, where we oversee all the programs under the Borneo Studies Network. So I would like to thank first and formally to the organizing committee from the different universities for the first ever Borneo Studies Network international webinar. I would like to congratulate all of you for a successful, hopefully, a webinar and a very fruitful one. I was asked to talk this morning very briefly to kind of introduce what BSN is about. So I'll do that very briefly for everybody, especially the participants who may not know what BSN is all about. So this BSN international webinar that is being hosted by our very good friends from the different universities, which is on renewable biomass-based materials and energy, is under the research group of renewable energy and advanced material. It is one of the research thrusts of Borneo Studies Network. So I believe this morning's discussion on biomass-based materials and energy, it would be a significant element in the gathering of researchers and students to discuss and share knowledge on Borneo energy and material science that has been done by the different universities. Okay. Now, the Borneo Studies Network is proud to support this event, and this event is one of our programs under the Borneo Studies Network. The Borneo Studies Network is actually comprised of 12 different major universities and research institutions in Borneo, coming from Kalimantan. We have a lot of members from Kalimantan, Indonesia, Sabah and Sarawak, Malaysia, and obviously Brunei Darussalam. So currently the chairmanship and the secretariat are being held by University Brunei Darussalam. So if there are any questions or queries about the different programs under the secretariat, you can do so by emailing us at bsn@ubd.edu.bn, or check out our website on borneostudies.org. Okay. So the aim of BSN, I'll be very brief. I know you want to start the event already. So the aim of this consortium is actually to facilitate research, in which this morning's event is supposed to do. It's not just about research, but also it has that teaching collaboration, in where I understand this morning's event is also the bringing together of graduate students, okay, across all forms of discipline and universities. So it is a consortium headed by people of Borneo studying about Borneo, as well as the Borneo and its relationship to the other regions. There are currently 5 research thrusts under the Borneo Studies Network, and obviously renewable energy and advanced material is one of them. The other research trusts are Borneo biodiversity, cultural heritage and ethnic groups, sustainable community transformation, and economy and banking. So we welcome participants or interested parties, especially from our member universities, to come and do research with the other universities within the BSM collaboration or consortium. Okay. So we identified all these different research trusts, including the energy and materials one, because we felt that it is important, particularly with the ongoing urbanization and development processes that's going on in Borneo, as well as the global impacts such as what we see today with the COVID-19, which has brought about new way of life, new way of conducting our lives, as well as new way of doing research as well. We've also done several undergraduate and graduate activities, such as the Borneo Youth Leadership Camp and Young Researchers Workshop. All this is about collaboration between the different members of the consortium. So though we are still impacted by the ongoing COVID-19, we hope to continue our programs and research collaborations with member institutions, though from a distance, as we are today. But this event this morning is a good example of how we overcome the distance and the issues that we are facing in current situation. So congratulations to all of you. So finally, I wish the facilitators, the speakers, the participants a very fruitful and productive session. And I hope we will meet again, inshallah, if not from afar, but also in person. Yeah. And may Allah grant you all a good health. May Allah grant you good health, particularly in this unique and trying time. Amin, amin, ya Rabbal Alamin. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. So, thank you very much, Dr. Hasarina, for officially welcoming the webinar. And now we are arrived to the awaited session. So I would like to give the time Dr. Rosna Abdullah to present her material about 15 minutes. And welcome to the speaker, Dr. Rosna Abdullah from University Brunei Darussalam, to deliver her presentation with the topic Biomass Energy Potential in Brunei Darussalam, an overview. Dr. Rosna Abdullah, please, time is yours.
Thank you, Dr. Shalina and Dr. Lucy. Okay, let me share the screen with you. Okay. Bismillahirrahmanirrahim. Assalamualaikum and very good morning to all. I'm Rosna Abdullah from the Center of Advanced Material and Energy Science of University of Brunei Darussalam. I would like to share my view on the current theme with the presentation entitled Biomass Energy Potential in Brunei, an overview. Okay, before I go further, let me just introduce you what is CAMS. CAMS is actually a center, research center located in University of Brunei Darussalam. We are one of the active research center. CAMS, the short form is CAMS, are actually providing a platform for researchers from various fields to come together to conceptualize ideas, find solutions to problems pertaining to energy and also advanced materials. And our main mission is to support economic diversification through innovation and also high quality graduate trainings. And our research core are nanotechnology as well as renewable energy, as you can see from the slide. And our primary function is to conduct research in the fields of energy and advanced material for the purpose of attaining sustainable living. We offer graduate programs only in energy and energy sciences as also material sciences. So if you would like to know further, you can just go to visit CAM's website on that link. Okay, now let's move on to the actual things to do today. Okay, let me start with introducing Brunei. This is with this Brunei's profile. Okay, so we are located in Borneo Island. Though we are neighbors, some of well, some people don't know where Brunei is. The capital city of Brunei is Bandar Seri Begawan. We are, if you can see, we are situated in this small piece of land in Borneo Island, surrounded by Sabah and Sarawak, with an area of 5,765 square kilometer. Our population is less than 500,000, and most of our country is still covered by forests. And our revenue is mostly based on oil and gas. So if you look at these red circles there, it's mostly the towns and city of Brunei, where it's mostly densely populated area. And those are the places where most of the activities are done within the country. So the rest are still covered with forests. So we have what we call as Brunei Vision 2035. And most of our activities and also mandates from the government will be based on this. So the aim is to turn Brunei into a nation widely recognized for the accomplishments of its well-educated and highly skilled people, measured by the highest international standard, as well as we want to make sure the quality of life is among the top 10 nations in the world. And we also want to see a dynamic and sustainable economy with income per capita as among the top countries in the world. And for the energy, we have what we call as Brunei Energy White Paper. It has been established not a long time ago. I think it's less than 10 years now. We have this mission and the still vision and mission to have sustainable energy for Brunei Darussalam's prosperity, as well as to drive Brunei's economy into a sustainable future. So under this energy white paper, we have 3 strategic goals. One is to strengthen the growth of oil and gas upstream and downstream activities. Second one, to ensure safe, secure, reliable, and efficient supply of energy, use of energy. And the third one is to maximize economic spin-off from energy industry, which means to boost local content and secure high participations of local workforce. So the work for today's presentation is mostly related to strategic goals number 2. We would like to contribute to this area, yeah, to supply, to secure reliable, efficient supply of use of energy. So in Brunei, before I go further, in these strategic goals, we have this renewable energy in the total. We want to contribute renewable energy in the total power generation that comes from resources which can be naturally replenished, such as from solar and waste to energy. So I highlighted there from waste to energy. So we are concentrating on this part for this work. So currently Brunei only have installed 1.2 megawatt solar power plant as a pilot project. So there's no other biomass renewable energy involved. And let me just bring you to the current scenario. So Brunei actually relies majorly on fossil fuels for its national energy security and also booming economy. That's why we have minimal interest in the use of renewable energy. However, because of worldwide interest on renewable energy, and also we want to diversify its energy sources and strengthen its energy security. So we want to see, and we set out a goal of adopting 10% electricity from renewable energies by 2035. So what sort of renewable energy potentials do we have? So there was one study done by our university. We have quite good energy potential from solar. We have theoretical possible annual potential from wave, tidal, and also offshore wind power. Because today's today's theme is on biomass, so it falls under bioenergy. So we have estimated estimated potential energy generated up to about 47 gigajoules per year. I think it's quite an impressive amount of energy. So that's as an overall overview, yeah. So under that, we have what we call as potential biomass resources. For this purpose, I only mentioned 3 different biomass resources, which is municipal solid waste, agricultural waste, and also woody biomass. So for municipal solid waste, well, this is not good because Brunei is considered as one of the highest waste disposal society per capita. We generate about 1.4 kilogram of waste or garbage per person per day. So you can imagine how much that amount for, let's say, about 400,000 people. But on top of that, we can see that it's going to be a reliable source of MSW. So annual average MSW was found to be around 190 kilotons. So it's quite a reliable sources. And our MSW mostly consists of food, paper, plastic, metal, glass, and others. Others mean rubber, textile, diapers, and so on. So the estimated annual production is quite high for food, and 18% for paper, 16% for plastic, 4% for metals, glass and others about 26%. So we have quite good resource of SW. And I just combined the woody biomass and also agricultural waste. Approximately, we have about 8.8 gigajoules of annual biomass energy potential. And Brunei mostly recycle the agricultural waste through composting. So we don't have so much agricultural activity for the purpose of bioenergy application. And we have various agricultural solid waste such as coconut shell, coconut fiber, corn fiber, rice husk, and sawdust. And that's the amount of energy potential that we have per year in millions gigajoules. So let's just go through this briefly. It's a case study on woody biomass. We have abundant unused biomass leftovers as biofuel resources, an average about 380 tons of wood potential per hectare across the country. So we have a total number of 24 sawmills distributed in Belait here, in Tutong, and also in Temburong. None in, this is where the capital city is situated, so none in the center city. The sawmills are actually mostly a small scale because they're still using conventional machineries. So this is we did a sampling in this for different areas. We have sawdust and leftover of logging, after logging activity, and so on. So these are the wood samples that we use. I think these are quite common in Borneo perhaps, or even in Southeast Asia. We have this kering bulat, kapur batu, yellow meranti, white meranti, and so on. Yeah, and we use this wood sample for this analysis, and this is how we prepare doing the logging. And for this one, we use a sawdust, and we only use the sawdust which has a 500 micrometer in size. So this is the method that we use. We use acetone extraction, thermal analysis, and other analysis just to oversee these wood samples. And we, for this purpose, we only did until hollow cellulose just to find out how much hemi and also cellulose that can be obtained from these woods. So these are the chemical composition. You can see the most interesting part for chemical composition is of course the hollow cellulose, and more or less about 67 to 73% the hemi and total of hemi and cellulose, which is quite comparable with other types of woods or energy crops in other parts of the world. This is just a thermal analysis which has been done at different heating rate, 5 degrees per minute, 10 degrees per minute, and so on. But as you can see, the behaviors are quite the same and quite comparable with, we just compare with this result with one of the studies available. Okay. And this thermal degradation is just showing the step that may have corresponded for the hemi cellulose and also cellulose as well as lignin. We done the approximate analysis, and you can see that we have this much of volatile matter, which is around 65 to 68%. Again, which is quite comparable with other results from other parts of the world. We have around 30% of fixed carbon from these wood samples. These are the XRD patterns for quite similar for all of this wood. Mostly they are natural cellulose, and this is quite important to know because this will give an impact on what sort of treatment that we want to use to produce what we require in further process, bioenergy or biorefineries. Showing the next slide is showing you the SEM images of these different types of family of woods. And the most important part is this one is the calorific values of the wood samples. Is a standard measure of the energy content of a fuel. So it's a fundamental characteristic of a fuel which is useful for planning and also control combustion plants. Let me just skip this SEM because we only have a few minutes left. Okay, so what sort of things that can be done? So this slide showing you the capacity of biomass resources for different types of application under biorefineries, energy, medical application, and so on. So for wood biomass, we can do different conversion processes, hydrothermal, using heat, using chemical, which is very common, acid, alkali, hydrolysis, also enzymatic. So from these processes, we can obtain further products under biorefinery, or even under different process under biorefinery. So on top of that, what are the constraints? Because you see that Brunei have biomass potential for bioenergy purposes, but what sort of things that hinders this to happen? One is the competition, obviously competition with conventional fuel, because if you compare the price of the low unleaded petrol price of Brunei, which is only cost 50% of our money per liter, is very, very cheap as compared with renewable energy or biomass pricing in the market. So this is one of the things that makes biomass application in Brunei quite difficult. And the other thing is we have a higher conservation policy for various agricultural activities, such as cutting trees and logging. So what we can use is only the waste leftovers from these activities. And we don't have proper infrastructures. And also another thing is social acceptance, because of the lacking of knowledge and the know-how to process in the long run. So we come to the final slide. I've been discussing about biomass energy may become one of the alternative energy. It is possible. And the generations of solid waste is considerably fast and high due to the modern lifestyle for Brunei. And efficient conversion to bioenergy is possible, not only using traditional, perhaps using a more sophisticated process. We have MSW potential, which is about 189 kilotons per year. Agricultural and woody waste potential, which is about 8.8 gigajoules per year. And these constraints are actually the hindering bioenergy demands. So that will be my last slide. Thank you very much for listening. I give the session to Dr. Lucy.
Okay. Thank you very much, Dr. Rosna Abdullah, for giving such informative and interesting presentation. And before we go to the next presentation, so let me briefly explain the format and regulation of the presentation. So all the participants of this webinar may post of your opinions, ask questions, and state any comments in relation of our topic this morning on your tools of Q&A chat. Or if you want to ask questions directly, you can raise your hand using the tools in your Zoom windows. And now is the second presentation will be delivered by Pak Made Dirga from Universitas Palangkaraya. Pak Made Dirga will deliver his presentation with the topic Utilization and Challenges of Palm Oil Byproduct as an Energy Source in Central Kalimantan. Pak Made Dirga, please, time is yours.
Okay, thank you, Dr. Lucy, for the time. Good morning, everyone. Wait, I will share my PPT first. Okay, good morning, everyone. Tabe salamat linguna latai, salam sujud karende malempang, adil katarinu, wacuramin kasaruga, basengat kajubata. Arus. That is our authentic salam from Central Borneo or Kalimantan Tengah. Okay, before I start my PPT, let me introduce myself. My name is Made Dirgantara. I'm from Physics Department, Faculty of Mathematics and Natural Science, University of Palangkaraya. You can contact me on dirgantaramade@mipa.gpr.ic.id. Okay, before we start, talk about bioenergy in Central Kalimantan or Kalimantan Tengah. I will introduce you. Where is Palangkaraya? Palangkaraya is in Kalimantan Tengah, region Indonesia, Kalimantan Tengah province. This is Palangkaraya, This is the iconic of Palangkaraya, Kahayan Bridge, and Kahayan Rivers. This is a Tugu of Tugu Soekarno, we call, where Palangkaraya cities began. And this is University of Palangkaraya. Welcome. And this is our authentic, maybe Black River in Sebango National Park. And this is me where it's in Sebango National Parks. Okay, let's start the outline. This first overview of palm oil industry in Indonesia, and then utilization empty fruit bunches, and then utilization of palm kernel cell, and the last is challenges. Maybe I will not talk the detail about the utilization, just the general. Okay, let first overview of palm oil in Indonesia. We know Indonesia is the highest or the largest production of CPO in the world. In 2070, Indonesia is 45% production of the total production in the world, with 36 million ton production. That is data from 2070. But in the last year, in 2019, the total production in Indonesia is increased almost 10 million ton in 45, 86 million ton. And this is the 5 province in Indonesia with the highest palm oil production in 2019. Kalimantan is the second. That's why I more focus on byproduct from palm oil production in Central Kalimantan, 7.75 million tons in 2019, last year. Okay. This is a product from 1 ton fresh fruit bunches. Wait, can see FFB. We have 23% CPO, 5% palm kernel cell, 22% empty fruit bunches or EFB, and 50% palm oil meal effluent or POM. From all of this, we can convert to bioenergy, like CPO, we can convert to biodiesel, palm kernel cell, nowadays as a co-firing coal in the steam power plant. And we can convert to briquettes, and the EFB we can convert to biogas, and pellet, and POME we can convert to biogas. But today I will focus more about a solid byproduct. This is empty fruit bunches and cells, palm kernel cells, what I work it. Okay, this is palm oil production system in Indonesia. I take this from LCA analyze. The red sign is indicated the high impact environmental. We'll talk it later, but now we focus on product from oil mill. Product from oil mill is the byproduct fiber and MVC fruit bunches. EFP. Okay. No, what Palangkaraya, University Palangkaraya already do about the utilization empty fruit bunches is the first conversion AP to biogas. AP from oil mill has high lignin and cellulose. That's why if we use that directly on the land, the biodegradation is need a long time because EFB has a high lignin. We can use EFB to straw mushroom cultivation first, and straw mushroom is degrade lignin to the smaller or the degrade lignin, and it's mean easy to make the cellulose convert to biogas. This is biogas after straw mushroom cultivation. We can use the AFB to be a raw material for biogas. And then in the biogas process, we still need a cow dung to be a starter, and then we can use this to compost. As this project is supported by Ministry of Environmental and Forestry, Republic of Indonesia in Katingan, Kalimantan Tengah. This is what we already do. This is EFB. We can use EFB as a mushroom cultivation, straw mushroom. Yeah, we know on the left we can see the EFB already have economic value, and the middle is for gas production, digester. This is in the top is dry digester, and in the bottom is wet digester. This is fire produced by biogas. This already do in Katingan, Kalimantan Tengah. And then next, EFB to pellet. Now I talk to EFB to pellet. This is supported by Ministry of Energy and Mineral Resources in Republic of Indonesia. Why we need to convert the biomass to maybe to pellet or to biogas? Because this is 70% LPG, liquid petroleum gas in Indonesia is come from import, and this impact on the subsidy by Indonesian government. In 2018, 64 trillion rupiah. This is very hard to our government to maybe because of that we need to have an alternative to decrease the import LPG in Indonesia. Okay, this is our maybe our new project to convert EFB to pellet and organic fertilizer. We start with EFB, and we can convert EFB by non-carbonized process. We can have pellet maybe more than 4,000 calories per gram. This is a caloric value. And then in the process to pellet, to make a pellet, we have a byproduct is like a liquid. This is can be used as organic fertilizer. We can bring back this to the palm oil plantation and go back to oil mill, the product of palm oil. This way, I think this is good for every part of this industry. And from pellet, we can have a biochar. After we burn the pellet, we will have a biochar, and this is good for fertilizer. This is where we try to burn the pellet with you can see that's the pellet. Okay, by use non-carbonized pre-treatment process, maybe 3.5 ton of EFB can be converted into 1 ton of EFB pellets and 170 kilogram of EFB organics. And sorry. 8 kilogram pellet, we already calculate conversion pellet to LPG. 8 kilogram pellets equal to 3 kilogram LPG. 1 kilogram pellet we calculate in 1,250 rupiah. That's more cheaper than LPG today in Kalimantan. LPG price today in Kalimantan. That's what we already do. And then utilization of palm kernel cell. This is one of my research. I work in palm kernel cell. Palm kernel cell is the highest caloric value in all part of palm oil. Today's palm kernel cells using as co-firing, coal co-firing for steam power plant is already do in Kalimantan Timur, and then raw material for biomass power plant, and also for for a boiler in oil mill. They use palm kernel cell to be a raw material for boiler in their oil mill. But we can increase the value of palm kernel cell with torrefaction or thermochemical process or others like pyrolysis, like hydrothermal, what Dr. Rosna doing, and others. But today's I work with torrefaction. With torrefaction, this is a mild pyrolysis, like in the range temperature 200 until 300 degrees Celsius. With torrefaction process, we can increase the caloric value until 5,500, 9,000, 6,600 calorie per gram. 6,600 calorie per gram. Yeah, we can increase the caloric value, and in the torrefaction process, we also have byproduct that is liquid smoke, who have a dominant acetic acid and phenol. This is a valuable chemical. We can sell this maybe higher than torrefied palm kernel. We also surprised the acetic acid and phenol is very high on the liquid smoke produced from torrefaction process, torrefaction palm kernel cell process. And then we can use this torrefied palm kernel cell directly on the co-firing steam power plant, or we can make other product like a briquette. Briquette is maybe 10,000 rupiah per 1 kilogram, and palm kernel cell is just 500 rupiah per 1 kilogram. We can increase the value of the economic value of palm kernel cell as a briquette, and we can use this to the community. This utilization of palm kernel cell with torrefaction process is supported by BPDKS, who manage the industry, the palm oil industry in Indonesia. And then, okay, this is all of utilization palm kernel cell, what UPR already do. And then challenges, okay, this is maybe one of important. Okay, first is pro and con, the contra of palm oil. The pro is already talk about economy issue, improve of the economy. The economy increase region income, triggers and develop facility infrastructure in remote area. We know, like for education, for healthy, the road in the remote area where palm oil is grown. And then the contra is, I always talk about environmental issue. increase emission from plantation due to failed technical food productivity, increase emission from palm oil mills due to process and waste generate, and increase in CPO productivity, also increase the waste or the byproduct of the palm oil. So from this, what we will decide, we will stop it or we have a solution. Maybe we will try to have solution to this environmental issue, because when we compare the palm oil with others oil crop plant, palm oil has the highest production in 1 hectare, per hectare, maybe almost 4 times or 5 times others in 1 hectare. So if you choose to stop this palm oil and change to sunflower or others, maybe it can make more environmental impact. Now the government is stopped to the new area of palm oil. That is good. And what we will do to solve the environmental issue? This is from LCA analyze. Applying technology to reduce emission. This is, I think, good for applying in the palm oil industry. Some of industries already do this, and they can reduce the emission. Like maybe my previous slide about red sign or red box, that is a high impact on environmental. This is a critical point emission. Wait, remote. Where is fine science? Okay. This is critical emission on productivity. The government stopped to open new area for palm oil, and then we need to increase the productivity, like in Central Borneo or Central Kalimantan, Kalimantan Tengah. In 2018, we have 6 million tons productivity in Kalimantan Tengah, and in 2019 we have 7.7, almost 1 million ton in 1 year. This is high productivity increasing. This is will reduce 50% emission. And the palm, palm has large methane. The current treatment is open lagoon without methane capture plant, but some oil mill or oil industry, we already use growing of number methane capture plant to use the palm as a biogas and then convert to electricity. And EFB just dumping. We can use this fertilizer or energy or mushroom cultivations or others to reduce the emission from EFB and sell. We can convert, fully convert cell to the energy. This will also reduce the emission front and trunk in plantation. We also can use this to energy. Maybe I will try it. But today is used as animal feed and furniture to replace the forest wood. Pest management, we can use natural predator to reduce the emission, and increasing UER is the palm oil mill. This is increase production efficiency of CPO. High efficiency will reduce the emission. This reduction is without without calculate the other impact, like if we use palm kernel cell to replace or substitute coal, it's mean we reduce the coal emission. Maybe with good management, this palm industry will have a good impact to the environment. Okay. Sorry. And then next. Okay. And then what is other challenge to convert all of the part palm oil to energy is the company is already in the comfort zone with CPO production, and that's why they want to invest more to have a facility for maybe biogas from home or pellet from EFB. They are already in the comfort zone with the CPO production. That's why we need the government to have a policy and to make the company or the entrepreneur in palm oil industry to utilize all of part the palm oil. Like my previous slide, we can utilize maybe all or part of the palm oil. Okay, this is my last slide. The conclusion. I have two conclusion of my presentation today. First is palm oil has a very high potential to be used as an energy source. We know every part of palm oil we can convert to energy. With proper management in the palm oil industry, the impact on the environment can be minimized, and it's also support reducing the use of fossil fuel. Maybe it will be make a more benefit or good impact in environment. Okay. Okay, thank you for Borneo Studies Network and all panelists in this webinar. I bring back to Dr. Lucy. That's all, Dr. Lucy. Thank you. Dr. Lucy?
Well, ladies and gentlemen. Oh, okay, yes. Hello, Pak Dirga.
Yeah.
Hello, all. Yes, thank you very much, Pak Dirga, for such informative and interesting presentation. And before we start to continue to the third presentation, I would like to remind to all the participants of this webinar, if you have the questions and opinions or any comments, you can use the tools by raise hand in your Zoom windows, or you can chat your questions in the Q&A chat. And then now we come to the third presentation, and this presentation will be delivered by Ibu Sri Rezeki from Universitas Tanjung Pura, West Borneo. Bu Sri will deliver her talk with the topic Prospect of Converting Biomass-based Material into Energy in West Kalimantan.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for the moderator who give me the chance to give this presentation. Perhaps you all can hear me clearly because here I have the heavy rain. My presentations today is about prospects of converting biomass-based materials into energy in West Kalimantan. Let me introduce myself first. My name is Rizky. I'm from Department of Chemical Engineering, University of Tanjung Pura. So here is the map of West Borneo. And the below one is the picture of Tanjung Pura University. Tanjung Pura University is on Pontianak, West Kalimantan. So Pontianak here. So I start from the definition of biomass. What is biomass? Biomass is the term to describe all organic matter existing on the Earth's surface. It's included agricultural crops and residue, forestry crops, sewage, municipal solid waste, animal residue, industrial residues, and others. So how to convert biomass to energy? There are several ways to convert biomass to energy. The first is direct combustion, pyrolysis, digestion, fermentation, and extraction, followed by transesterification. We will discuss it one by one. This is direct combustion method. Maybe this is the simplest method compared with the others, because we just only do some pre-treatments like make the biomass dried and then supply it to combustion, so it can hit the boiler and the boiler produce steam and it will turn the turbine and it will produce energy. How about the potential of biomass in West Kalimantan to convert by direct combustion? So I have the data from municipal solid waste and agricultural residue. I only have data from 3 cities and regencies in West Kalimantan. So the quantity per day for the capital city of West Kalimantan is around 400 tons per day. For Sambas, almost 500 tons per day. And for Ngabang Regency is around 9,000 tons per day. I can found any data from 11 other regencies. So I try to convert this municipal solid waste to energy. Then we will have around 86,000 megawatt hour for MSW in Pontianak, 97,000 megawatt hour for municipal solid waste in Sambas, and more than 1 million megawatt hour for municipal solid waste in Ngabang. And also in agricultural residue, West Kalimantan has 20,000 tons agricultural residue. So when it so we will have 13 million megawatt hour from direct combustion. The 20 million ton agricultural residue, I collect the data from this plantation. In West Kalimantan, we have rubber, coconut, hybrid coconut, palm, cacao, coffee, garlic, clove, candlenut, areca nut, sugarcane, sugar palm, rice, and corn. So we have the productive plants and also non-productive plants. Non-productive plants is the plants that is broken or we can get the crop because of disaster, pests, and others. And this is the conversion. In the 1 hectare of rubber, it will have 100 trees per hectare. For coconut, 143 trees per hectare, and then we can calculate it, the trees in non-productive area. I just calculate the energy from the non-productive area. So I didn't use it because it will use to produce food and others. So from the agricultural residue, we have in total 20 million tons agricultural residues. How about in pyrolysis? In pyrolysis, the biomass can convert into 3 products. They are gas, and also char, and also bio-oil. This is the data when I convert the biomass into energy by pyrolysis. So we can get the 142 million megajoule gas, 476 million liquid, and 428 million megajoule char. Then the third method is digestion. In the digestion process, we can also use the biomass such as animal manure, energy crops, and food waste, and we send it into an anaerobic digester, and then it will produce biogas. And then we can extract the methane and then use it as fuel for vehicle, or use it to produce electricity. And this is, I try to calculate it, the biomass potential from the animal waste, from beef cattle, dairy cows, buffaloes, goats, swine, and poultry in West Kalimantan. So we will have 700,000, almost 800,000 meter cubic biogas per day, and it is equal with 1,500 kilowatt hour biogas per day, electricity per day. And the fourth method, we can use fermentation, where biomass we send to pre-treatment way, make it small, and then send it to some process, hydrolysis, fermentation, followed by distillation, so we can get the ethanol. This is some plants that we can use as raw material to produce the bioethanol: rubber, coconut, hybrid coconut, palm, cacao, coffee, garlic, clove, candle nut, pinang is areca nut, sugar cane, sugar palm. And the potential of bioethanol, you can see in the next slides. And also from the rice, corn. For the rice and corn, I just get the residue like straw and others. I didn't use the rice itself and the corn because it for the food needed. So I can calculated the residue and convert it into energy. So we can have 9 million megawatt hour from rice residue and 300,000 megawatt hour for corn residue. And all in all, for bioethanol, we can get the 6 million kiloliter from the agricultural residue. And it's equal with 9 million megawatt hour electricity. So the last method in my presentation is trans-esterification. We can do this method trans-esterification by extract the plant's material to get the oil and fats, and then we do some pre-treatment and add some catalyst and methanol for next do the trans-esterification, and after washing and drying we will get the biodiesel. This is some plants that have potential to be extracted and esterificated to be biodiesel, such as palm, coconut, hybrid coconut, soybean, peanut, cacao, rubber. And this is amount of the plants in West Kalimantan. And then from the conversion, we will get 1 million kiloliter of biodiesel. So what is the challenges to convert biomass into energy in West Kalimantan? The first is the land is defragmented from one to another's, and the second is the most of the farmers are small or marginal, so they difficult to access the information and also the facilities, and also the government policy it need the hard will to use biomass as the energy resource. And also the transportation cost from one area to another area, it's also not cheap. So the conclusions from the several methods, in West Kalimantan we will get 13 million megawatt hour from direct combustion, where the raw material is MSW and MSW and agricultural residues. And from the pyrolysis, we can get around 300 megawatt hour from municipal solid waste and agricultural residues. And from digestion process, we can get 1,500 megawatt hour per day from animal waste. And from the fermentation process, we can get around 9 million and a half megawatt hour with the material agricultural residues and some crops. And from the esterifications, we can get 2 million megawatt hour from crops oil. So that's all my presentations. Many thanks for your attentions. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, well, thank you very much, Ibu Sri Rezeki, for the presentation. So I think we have already received questions, but before we answer the questions one by one, we will continue for the last presentation. And in our last presentation, will be delivered by Dr. Sunardi from Universitas Lambung Mangkurat. Dr. Sunardi will deliver his presentation with the topic wetland-based biomass for functional material. Dr. Sunardi, please, the time is yours.
Thank you, Dr. Lucy. Thank you, Dr. Hasarina from Borneo Studies Network. Good morning, everybody. In this moment, I would like share about wetland-based biomass for functional materials. challenge and opportunity of nanocellulose. Maybe rather different with the other presenter. My name is Sunarti. I came from Chemistry Department, Faculty of Mathematics and Natural Science, Lambung Mangkurat University, and Wetland-based Material Research Group, Lambung Mangkurat University. Thank you. But before we discuss about wetland, please let me to introduce my institution, Universitas Lambung Mangkurat. Universitas Lambung Mangkurat, located in South Kalimantan, maybe in the smallest province in Borneo. Here, and our mascot is the floating market. Maybe some people have come here. And Universitas Lambung Mangkurat have 3 campuses actually in Banjarmasin, 2 campuses in Banjarmasin and 1 campus in Banjarbaru. And we have more than 100 study program from diploma until doctoral program. And the distance of our campus is about 40 kilometers. So that is a very long distance if we must every day go to the campus 1 or campus 2. And our vision is to be leading and competitive university in the field of wetland environment. So why our focus research is also in wetland environment? Because our target we can to be the center of excellence in wetland environment. Okay, wetland. What is a wetland? Some people said wetland as a wasteland atau lahan sampah. Because this wetland, the condition sometimes is very marginal. The area always covered by water during all year. So very limited activity can do in this area. And according to Ramsar Convention, peatland and swampland is also categories in wetland area. You know, wetland in Indonesia is the second biggest wetland after Brazil. In Sumatra, more than 7 million hectares, and in Kalimantan, almost 6 million hectares of wetland. This is the photograph of the biggest peatland in Kalimantan in Sebango National Park, Central Kalimantan. And because the condition, some people also assume that wetland is a problem. Why wetland is a problem? Because wetland ecosystem have low productivity, and this land also marginal and cannot be utilized because always covered by water. We remember that in 1995, President Soeharto declared program lahan gambut 1 juta hektar, 1 million hektar peatland program for converting the wetland to the rice farming. But this program failed. And now President Jokowi also declared the new program Strategis Nasional, to make Central Kalimantan as a food estate or lumbung pangan. Hopefully this program can success. And we remember that almost every year we have sad story, especially in South Kalimantan and Sumatra. Forest and land fire or kebakaran hutan dan lahan always happen. And every year we export smoke disaster to Brunei, Malaysia, and Singapore. And that is a big problem for us. This is the picture when people try to stop burning peatland. And this picture is a condition. I took this picture at 11 September 2018 at about 8 morning. Very thick smoke around in the sky. So when condition happen, we must wear mask. Not only when this now, but in COVID, but when smoke disaster happen. But wetland also a potential, a big potential, because wetland support the development and life of the Indonesian people. Hundreds or maybe 1,000 million people depended on the wetland. And wetland also to be a water regulation and biggest carbon storage in the world. Wetland also have 1,000 biodiversity. So that is a big potential for us. This is the condition of wetland in South Kalimantan. Some wetland also changed to palm oil plantation, like in Central Kalimantan, like Mr. Dirga presented. But some parts still also naturally. This is the sago plantation, and this is the rice farming in Jejanggit, Barito Kuala. And this is the vegetable farming by local people. This is near Samsudin North Airport. Besides convert wetland to the other function, might be for palm oil plantation, naturally, wetland have the indigenous plant that's called paludiculture. Paludiculture is a native plant in wetland, swampland, and peatland, and they can grow well without drainage in the acid condition. According to the DIGESTION, 1,000 higher plant species have been recorded in swamp forest, and more than 500 species have a non-use. In wetland also found more than 200 useful timber, more than 200 known to have a medicinal use. Maybe in the last case is Bajagah Tunggal from Central Kalimantan that is very famous last year. And many plants can use as food source and other uses like latex, fuel, and dyes. So paludiculture is a sustainable alternative of wetland management. This is categories of paludiculture species. Some plant is quick harvest. Some plant proven commercial crops might be quick harvest, and proven commercial crop have used by local people. And some plant is still unproven commercial crop, and this is need advanced research. This is an example of some paludiculture plants that cultivated by local people. Sagu, main use for starch or food and feed sources. Nipah, that is for sugar and maybe second generation bioethanol. Gelar, Melaleuca cayuput, the main use is for construction, firewood, and essential oil. And the next is Purunticus, Eleocharis deltis. The main use is for fiber, for make handicraft in South Kalimantan. And some plant is a wood, like Jelutung Rawa for latex and furniture. I'm sorry, the picture lost. And Meranti Merah for construction. So this is the data from Amirta et al. 2019 about plant species located in swamp forest, but the location in the East Kalimantan. Many plant species have found, and this plant also have use for local people for many utilization like firewood, construction, medicine, and others. So all of this, all of the paludiculture is a source of sustainable biomass. What is a biomass? Dr. Sri Rezeki have discussed about that. So all of this sustainable biomass, especially from wetland area. And this is the potential of wetland as a sustainable biomass source. We know all of biomass comprise three main components. The first is cellulose, hemicellulose, and lignin. And the other additional component like extractive and mineral ore. And this is the hypothetical diagram of the composition of biomass: lignin, hemicellulose, and cellulose. And this is the chemical composition of paludiculture from South Kalimantan. From sago or metroxylon, we can get biomass from bark, hampas, and frond pulp. And from nipah, we also can get biomass from husk, seal, frond leaf. And from Gilam, Elocharis turkis, this is the composition of cellulose, hemicellulose, and lignin. From this data, we know that the chemical content of biomass, chemical content of cellulose is more than 30%. That is very high number. So we can use this for the other material, not only energy. This is research about lignocellulosic material. We know biomass lignocellulosic material have used for produce biofuel, like Mr. Dirga research, Dr. Rosna Abdullah research, and others. And for enzyme production, this is the lignocellulose biomass can be substrate for white root fungi. Biomass also can use for animal food, composite, fine chemical, and pulp and paper. This is a detail of cellulose-derived product from cellulose or C6 sugar. We can use for paper product, fiber, biofuel, consumable, bioplastic, and chemical. And this is hemicellulose-derived product. Hemicellulose is a C5 content in the hemicellulose. This material, all this component of wood, can use for produce biofuel, chemical, and this is xylitol. Xylitol is a sugar, low calorie sugar. Maybe we often find in supermarket xylitol gum, and this is very expensive. This product came from hemicellulose, from wood or non-wood material. And this is the lignin derived product, also can use for energy, chemical, resin, fiber, and other products. So biomass is very useful. And other function, maybe if we focus on cellulose, we have a big challenge and opportunity to produce nanocellulose, especially from wetland biomass. Nanocellulose is the cellulose in nanoscale, in size 1 until 100 nanometer. And this is the picture of nanocellulose. This is the size of nanocellulose. We can compare with wood in the macro size. This is a nano size. This picture is the research from our research. This is nanocellulose from Nipa fruticans, and we saw that picture A, the suspension is sedimented in the few minutes. This indicate the size of cellulose is still big, but in the C picture, we know the suspension is very stable. It indicates that nanocellulose have produced in this research. This is the easy indication when we produce nanocellulose. Okay, this is the picture. Okay, how to produce nanocellulose? From wood or non-wood material, the first step is pre-treatment to remove lignin and hemicellulose. And we only get the cellulose. And after that, we can acid hydrolysis using sulfate acid and maybe HCl to remove the amorph region and remain the crystalline part. So we can get nanocrystal cellulose. Why nanocellulose is very important for us? Because nanocellulose different with nanomaterial, other nanomaterial, maybe from inorganic material, nanocellulose is very sustainable because cellulose also sustainable, renewable and abundant, especially in Borneo. And nanocellulose also green disposal, easy to degradable, and very biocompatible. Nanocellulose also have high aspect ratio and high surface area. This condition make properties of nanocellulose is very perfect. And if we use nanocellulose for enforcement or for filler, maybe composite and plastic, the product will have high strength and high modulus, and also high thermal stability. And nanocellulose also have the unique character. The surface of nanocellulose can be modified to get other properties, maybe from hydrophilic to hydrophobic. This is some application of nanocellulose from contraction, from filtration, maybe di sini to make a membrane, to implant a biomaterial for packaging, composite, hydrogel, pulp and paper with functional using, and for electronic sensor. Very large application in industry. And this is the example of nanocellulose as a biomaterial function for skin application, artificial human part, cosmetic, and delivery system. And we can also modify the nanocellulose for other function, maybe for super hydrophobic nanocrystal cellulose. This nanocellulose can use for oil absorbent because the surface to be hydrophobic. Nanocellulose can also for antimicrobial using modifying the surface. And our focus research is for drug delivery. We can modify the nanocellulose, can appropriate with a drug to slow release drug delivery. If we see the data of publication about nanocellulose based on the Scopus data, we can see that the publication about nanocellulose is significantly increased in the 5 years since maybe in the 2012, only about 100 publications published in index-based Scopus. But in 2019, more than 1,000 publications have published. And until the end of June, more than 700 publications have published in Scopus. So it's a very interesting publication. And if we see from country, the China is dominated the publication, and the country from South Asia, only Malaysia have publication about nanocellulose in the significant number, because we know Malaysia also have the big plant of palm oil, and the nanocellulose from Malaysia based on the palm oil biomass. This is the prospective demand of nanocellulose in the world. Every year, the demand more than 23 million tons per year. Very big number for us. And the doses of the nanocellulose for adding in some industry only low percent, about 0.5 until 5%. But the additional of nanocellulose can improve the character of the material, like paper, textile, and other material. If we see about the price of nanocellulose, that is also very expensive. In the suspension condition, about 1 until 3% in solid water, the price is more than $2 per gram. And the dry condition, the price is about $8 per gram. This is the commercial cellulose nanofibril. And for nanocrystal cellulose, and the price also high. For the suspension, per gram is about $3, and for dry condition or dry nanocellulose, the price is about $8 per gram. So that is very expensive price if we can make a cellulose from the abundant material. This is an example of our research, preparation of and characterization of nanocrystalline cellulose from wetland plant, Eleosaris dalgis or Purunticus, have accepted in Material Science Forum. This is the picture of our suspension. And this is the size. The size of our nanocellulose is about 70 nanometer. And the second, this is our patent that I have submitted about formulation of transparent bioplastic with dissolved cellulose. So in this research, we added the dissolved cellulose to improve the character of bioplastic. With the addition of about 0.5% of dissolved cellulose, we can improve the mechanical strength of bioplastic more than 10 times, from 15 megapascal to 248 megapascal. So only with the small addition of dissolved cellulose, we can improve the properties of a bioplastic. This is the address of our research. We use cellulose from Nipa fruticans to make drug delivery agent of rifamycin. That rifamycin is the medicine for tuberculosis. From this data, we know that the addition of cellulose can improve the release of rifamycin. So the future prospect, homework for us, how to use wetland biomass as a sustainable nanomaterial source to make the a problem or marginal land to biomass source to make something material, new material that is a functional material to produce and get and to produce much money. So we can convert biomass wetland not only problem, but that is a big potential for us without degrade the function of wetland area. That's all. Thank you very much. This is my contact, sunardi@ulmasa.id. Thank you, Dr. Lucy.
Okay. Thank you, Dr. Sunardi, for the such informative and also interesting presentation. And well, ladies and gentlemen, thank you for your attention and your time still attend this webinar. So now we come to the most awaited session where you may post your opinions and then ask questions in relation to our topic this morning and the presentation just now. So I would like to ask the questions from the participants. So please wait, I will check. Okay, so we just get some questions for all the presenters today. So here are the questions. So for the first questions, I think this is for Dr. Rosnah Abdullah. So and she already answered for the typing answer anyway, but I think it's better if Dr. Rosnah explain once again virtually. And the first question is about the detail of technology that has been implemented in Brunei to produce energy from biomass, and which more effective to be biofuel product or in the form of gas. And then the other questions is about what kind of the transformation can we carry out on this compound to generate the bioenergy. This is for Dr. Rosnah. So I think Dr. Rosnah can explain or answer that questions virtually now. So Dr. Rosnah, please, time is yours.
Okay, thank you, Dr. Lucy. I can just read from what I've written here. But anyway, thank you for the questions from Karyani and also Ren Lim. For the first question, it was about details of the technology that has been implemented in Brunei to produce energy from biomass. As I mentioned in the slide, we haven't actually have a big sort of technology for productions of bioenergy. It is just done in the research center as well as universities, still under research basically, because we don't really have the urgency to use bioenergy. Okay, and for the other question, what kind of transformation that can be carried out on these compounds, which is hemicellulose and lignin. So I answered them. Well, more or less, here's the answer. For wood, as mentioned by the other presenters as well, we know that cellulose is the hardest part to be hydrolyzed. So we usually get rid of hemicellulose as well as lignin in order to reach the cellulose part. So the question is about hemicellulose and lignin. So the transformation process or the conversion processes for hemicellulose and as well as lignin, probably the same. Can whatever is used for cellulose can also be used for hemicellulose and lignin. It's just that the condition will be milder, probably lower temperature or lower heat is needed. The products from hemicellulose and lignin will also be different from what we obtain from cellulose because of the different chemical structure. Yes. So yeah, that's the answer from me for those two questions.
Well, so now is continue to the questions for Mr. Digantara. So Pak Made Dirga, time is yours.
Okay, sorry. Okay, sorry. This is maybe this question is okay. I need to repeat it. Where is the question? Dr. Lucy?
Yeah, hello.
Can you read the question for me?
Okay.
This...
The questions is from Institute Teknologi Kalimantan. Hello.
Yeah.
Institute Teknologi Kalimantan. So the question is two questions. The first question is asking about how long is the duration to produce biogas by using EFB method.
Yeah.
And the second question is what kind of the method did you apply to calculate the prediction of reduction CO2?
Yeah.
And I think this is the question. So the next questions will be delivered to Bu Sri Rezeki.
Okay, it's same with Mansub. The question is you mentioned about producing of gas using palm waste. Could you please explain more if possible? Okay, this is the digester to produce biogas from byproduct or AFB from cultivation of mushroom. Okay, this in the bottom, in the middle bottom, this is a dry digester where we put the EFB and sorry, maybe I need the pen spotlight. This is a wet digester where we put in cow dung, kotoran sapi. We still need kotoran sapi here to be a starter for convert the EFB to biogas. Yeah, on anaerobic. Maybe just that this is the we mix the digester, not just wet digester, but two kind of digester, dry digester for EFB and wet digester for cow dung as the starter for produce biogas. And then the dry digester need 10 days for produce biogas because the bacteria need to degrade the cellulose to convert to biogas. But in when we use cow dung or kotoran sapi, in the next day we can have the biogas. This is time about how I calculate. Actually, this wait. Where is my presentation? This. Actually, this is not my and calculate it by myself, but I take this from source. But I know maybe I will answer this method. It's using LCA, life cycle assessment. Maybe we'll answer LCA in Indonesia. LCA itu adalah sistem untuk pengukuran tidak hanya emisi, tapi semua semua dampak lingkungan dari hulu hingga ke hilir. Dari hulu hingga ke hilir. Jadi kita bisa menghitung nggak hanya emisi CO2, tapi juga bisa ke emisi cair, padat, dan lain sebagainya. Jadi kalau ingin, if you want to maybe calculate more about the impact, environmental impact, you can use LCA method. You can learn it or others, and the paper is already already maybe Indonesia LCA is new, but in other countries LCA is old method. But this is good for calculate environmental impact, and our Ministry of Environment and Forestry will use this as proper, maybe as a point to give one company is a green company, they have a good environmental management. Jadi untuk di Kementerian Lingkungan Hidup sendiri, LCA akan dipakai kepada perusahaan-perusahaan untuk mengukur dampak lingkungan yang mereka berikan. Jadi nanti di sana ada penilaian apakah dia masuk ke dalam hijau ataupun merah ataupun bisa jadi gold. Mungkin that's it all. Maybe one question again about mixing. About mixing palm kernel cell mixing palm kernel cell or mixing biomass with coal. That's according to your caloric value. Jadi tergantung nilai kalor yang digunakan saat itu, your initial caloric value of your raw material. Jadi kalau misal pakai kalor dengan when you use coal with low rank dengan rank yang rendah, maka kita bisa mengganti semua dengan with 4,200 kalori per gram, we can replace all coal. But the problem is the availability of the biomass. That is the problem, the availability. Jadi ketersediaan dari biomasnya itu bisa nggak cukup gitu, karena memang produksinya itu harus besar. Seperti di PLTU, we need large of biomass. Kalau misal pakai yang tinggi, ini torrefied palm kernel cell is if compared to coal, it's kind of maybe high rank, 5,500 and 6,600 is a high rank of coal. We can replace the high rank of coal. Then that's it. Today's PLTU is replace or substitute 5% of their coal to biomass with use palm kernel cell. Okay, thank you, Dr. Lucy.
Okay, well, thank you for your explanation, Pak Dirga. Pak, I think this is the last question that still related with your presentation. And the questions is asking about why so far, most companies use is much for oil palm trees. This is requires transportation and labor costs. But why the company is not interested in converting EFB into energy? And the second question is how to say this is so based on the analysis of economic and environmental aspect, which method provide the highest economic value and the smallest environmental impact, converting the bioenergy or conventional utilization as much. So I think this is me to answer from you.
Okay, I already answered it in the MBT because the company is already in comfort zone with the CPO production. That's why they don't want to. Why I should invest more when this is already good for me? But in my presentation, we know the potential of EAP is very high to produce an energy, and other problem is di Kalimantan Tengah sendiri beberapa industri yang we try to make a collaborate with the industry. Perusahaan itu berasal dari luar negeri. Jadi there are from Singapore, from China, from Malaysia. This is not from Indonesia. That's why maybe nationality is not high. But we try to make them believe you will have a benefit to this program, and the government. The government also support us maybe to utilize all part of the palm oil. Jadi masalah utamanya sebenarnya juga di situ. Ini sebenarnya sudah kita kalkulasi, ini menguntungkan baik itu bagi negara, bagi masyarakat di sekitar, bagi pemerintah sendiri untuk mengurangi ketergantungan terhadap gas. And then the problem with the use biomass as a fuel for community untuk masyarakat. Jadi kepraktisan dari kompor biomasa itu masih belum. Yeah, this is one problem. The biomass stove is, yeah, I think not perfect yet for using in the community. Jadi kepraktisan dari kompor biomasa tidak seperti kompor gas ketika diputar langsung hidup. Ini tidak, ini masih belum, dan masih banyak mungkin kepraktisan yang masih belum. But when the government decrease the subsidi, ya, jadi kalau pemerintah menurunkan subsidi, maka harga gas akan sangat tinggi di masyarakat. Maybe in that situation, the community will change to the biomass. And then, any question will I not answer yet, Dr. Lucy? Dr. Lucy, can you hear me? Dr. Lucy, anyone can hear me?
Yeah.
I
can. Yeah.
Connection of.
Okay. Jadi mungkin itu yang menjadi masalah. Masalah utama sebenarnya juga ada di perusahaan tersebut, karena perusahaan tersebut sudah berada di comfort zone, sehingga dia tidak mau investasi lebih, ke yang lain gitu. Padahal jika dimanfaatkan semua itu akan sangat baik. Tapi pemerintah juga sudah mulai menerapkan penilaian lingkungan yang lebih ketat untuk perusahaan-perusahaan seperti penggunaan LCA seperti tadi, life cycle assessment. untuk menilai perusahaan tersebut. Ya, kalau memang tidak baik, maka ya ini akan banyak denda-denda terhadap perusahaan tersebut, sehingga akan memaksa perusahaan tersebut untuk melakukan konversi biomas with all part of palm oil. Is it, Dr. Lucy? Dr. Lucy. Oh, maybe Bu Sri Rezeki, you can answer your question. We wait for Dr. Lucy.
To answer the question, the first
Yeah.
from Mr. Khan, is the data from Indonesia only that I mentioned it before? No, the data is only from West Kalimantan. So West Kalimantan is only one province is in Indonesia. We have another 32 province. So the data only for my province, West Kalimantan. The second question is is there any power plants in Indonesia using biomass waste? Yes, in Indonesia we have some power plants that using biomass waste, but the number of the power plant is still less. In 2018, in Indonesia only have 12% the energy source from the renewable energy, while the less around 88% is from fossil fuel. So we need to fulfill the target on 2025. We have to use 23% of renewable energy in Indonesia. That's a big challenge for us. So move to the the third question from Miss Nupi, which method is better? So it's very depends it's very depends because every method has the positive side and negative sides. Like the direct combustion, it's very simple way, but the gas emission is high for SOx and NOx and others. And like pyrolysis is a little bit difficult, but then we can get the three products from that method: the char, the oil, and the gas. And for the biogas, it's the way to get the clean energy, but it's really not easy to work with such animal waste. It's something very disgusting. And then also for the bioethanol, and it's also not really easy to work with microorganism because it needs special maintenance to make them grow. But the product is clean energy. And the last method is biodiesel. And for the biodiesel, we need the resource from the oil source, only from the oil source. That's the factors to determine which one is better method. That's, I think, for my answer. Who's next? Thank you for the questions.
Okay. For the time being, I'll take over from the still disconnected from our session. Let's just move on for find some questions for Dr. Snardi. Where is the question? Can't find any question for Dr. Snardi. Have you answered some of your question, Pak Sunardi?
I have answer in the Q&A, but
Maybe you can repeat the answer.
Yeah. So, what kind of crop that can be used as biomass? So, generally, all of biomass can be all of plant can be biomass sources, and all of plant might be residue, sisa-sisa tumbuhan. That is all is biomass, and all of this contain cellulose, hemicellulose, and lignin. Maybe only in the different amount of its component. So biomass is very abundant because we can get it from all of the plants. Maybe like that. And then the second question about the cost of produce nanocellulose. Yes, produce nanocellulose is very expensive, but if we have good tools, maybe using mechanical methods, that is very cheap. Maybe in Indonesia, Pusat Penelitian Biomaterial have the tool to make nanocellulose easily. And if we have that, we can produce nanocellulose in the easy method, and we can produce a big number of nanocellulose from our biomass. Maybe that is my answer, Dr. Rosna.
Dr. Lucy is back. Shall I pass this to Dr. Lucy?
Okay, I'm coming back. So I think all the questions already answered, right?
Yes.
Right. So I think it's better if all the presenters take some discussion or conclusion that can answer all the questions from the participants. And how to say, we finally, I think, and the time is already end. So we finally come to the end of this webinar. So before I close this webinar, I would like to take the opportunity, make the conclusion from what the speakers have presented. So the first is biomass is seen as one of the promising optional resources, and the environmental issue, especially the increase in emissions due to the technical field, culture, and CPO production process, are the main things contrast to the industry. And the other thing is, we need to has more how to say technology, especially in Borneo, to support the converting of the materials to be the bioenergy. So I think this is all the discussion for this webinar today. So I would like to thank you very much for the speakers for such informative and interesting presentation, and also to the participants for very active involvement. And hopefully this webinar is beneficial for everybody. And once again, thank you for the attention. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Lucy, mungkin info untuk semua partisipan, for all participant, we already record the attendance list. That's why, yeah, we already record the attendance list, and we will send electronic certificate for the attendance list in Zoom webinar.
Yeah. Oh yeah. Yeah. Before I close this seminar, so for the all participants, I think I already announced in via chat to the all participants who only attend this seminar fully from the beginning until the end will receive the certificate. And then for the confirmation and attendance links, I already write in the chat. And then also we will share how to say the topic, the file presentation today by email. So together with the certificate by email. Thank you very much. So any other take or comments?
No, thank you.
Okay, good afternoon all. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, I will end this on YouTube. And